Hey viewers, welcome back to our channel. Hope you're doing extremely well. So today we are going to discuss today we have a positive discussion on the topic of stack. Okay, so till now I'm expecting that you know how to use list in the Python what are arrays. Okay, and today we try to understand that what is a stack, what are the behavior of stack, how stack is implemented in Python, and how stack is different from the other linear data structures. Okay, so before moving on to the discussion, if you guys are new to our YouTube channel, then please do consider subscribing our YouTube channel. And by the way, Snam, let's try to understand it. Okay, so if I talk about the linear data structures, so there are some linear data structures. Let me write some of them. The one which is most commonly is known as arrays. Okay, the second, which is nothing but list in the Python. Okay, and if I talk about the C++, it is vectors, and if I talk about the Java, it is nothing but the array list. Okay, similarly, there is third, that is known as the linked list. These are the well-known linear data structures if I talk about. But so leave the okay, so at first is you might be thinking that how arrays are implemented in the Python. Okay, so what if I say that yes, we can implement the arrays in the Python, but for that we need to import some library that is nothing but the numpy, and we can only implement the numpy's array in Python. Okay, so if you don't know about the numpys, okay, I'm leaving the arrays and we will try to discuss only the list. Okay, so we know list is a well-known data structures. So not the data structure, data type in the Python. Okay, so there means when we try to implement some function, learning the list, we come to know that there are so many functions of the list, and we use those functions to implement our behavior. Okay, so we at first we will not discuss a particular data structures. We will just try to understand the approach. Okay, approach and the behavior of the data structure. If I talk about the linked list, okay, so what is the behavior of linked list? We assume right now currently I'm not going language specific, I'm just talking about the concept. Okay, so if I talk about the linked list, we assume that the nodes are connected in a linear manner, one after the another. Okay, each node is linked to its neighbor node by storing its address in itself. Okay, so we assume that it represents in a memory like this. We just assume it. Okay, so means this A node is storing the data of this B node somewhere here. Similarly, this B node is storing the data of this C node somewhere here, and we perform also along with this approach. These data structures give us some features to perform some type of operations. What were those operations? We know that we can add something, some node here in order of one-time complexity. Okay, similarly, what if I will say I can add something here at the very end in order of one-time complexity if I keep on tracking the end of a linked list, or if I if I say tail of a linked list. Okay, means if I store the tail of a linked list, if I keep on managing the tail, then I can also store some data, some node in the end of a linked list in order of one-time complexity. Similarly, I can remove a node from the beginning, or remove a node from the end of a linked list in order of one-time complexity. Okay, this is a features of these data structures. Features, if I talk about the features of this data structure, that is nothing but this data structure is linked list. Similarly, if I talk about the arrays, we know, we assume, okay, we don't assume, actually it obviously stores the data in contiguous memory allocation. These nodes in the linked list are not stored in contiguous memory allocation, but in the arrays we store the data in contiguous memory allocation, and usually we store the data of the same type. Means if we have created the array of the integer type, that it only stores the data of the integer. Means here it only stores the data of the integer, and I'm assuming 1 2 3 4 5 6. So this is an array nothing but of the size 6. Okay, so there are also some properties of the array. The one property is that during the declaration of the array, okay, we need to tell the size of an array. So here at first we need to tell that this array can store at max only 6 elements. Similarly, there are some other properties of the array, like random accessing is possible in array. Random accessing, Random accessing means if I want to access the elements which is stored at the index 4. So we know the indexing start in an array from 0, 0, 1, 2, 3, 4. So means I can easily access this 5. I can easily access this 5. I hope you get it, but I'm trying to explain. These are the properties of these array data structures. But we know that each data structures have some loopholes with them and have some problems with them. So we move on to some other data structures. Similarly, if I talk about the stack is a linear data structure. Means here also we store the data linearly one after the another. But as other data structures have some properties, similarly the stack must have some property. So what if I say the stack is a little bit different from the other data structures in a way that it restrict the user in a way in which we can access and add or delete the data. Okay, so let's try to understand how it restricts us. Okay, so usually whenever we talk about the stack, we assume that stack is created like this. Stack is usually created like this. We assume it. Okay, it is not mandatory, but we assume that we create the stack like this whenever we want to show its pictorial representation. Okay, so what the stack does, what are the properties of stack, and I said earlier that it restricts us, and let's try to understand it how it restricts us. Okay, so here I'm assuming that I have some elements which I need to add in the stack, like 1 2 3 4 5 6 and 7 and 8. Okay, I have these 8 elements. Now first thing is that adding a data into a stack. Okay, so what I'll do, I'll just pick that element and add it to here. I will add it. Okay, so it get inserted into the stack. Similarly, now I move further and I am going to add 2. Okay, so I'll add 2. Now the 3 get added. Now 4 get added. Now 5 get added. And you might be thinking that what I'm doing, it is just working similar like the other data structures, means the data get added one after the another. But here's a twisting point. Okay, means whenever I try to remove data from a stack, this 5 will not be deleted. Okay, means only the data which is inserted at first into a stack will be removed. So what I said. Okay, so let me write it here. The stack follows LIFO concept. What is this LIFO? The full form of this LIFO is last in first out. Okay, but if we talk about the removing of a data from a stack, then only that element will be removed out at first which is currently inserted. Means if I talk about removing an element from a stack, then this 5 should be removed at first. Okay, so at first this 5 will be removed out. Now again, if I talk about the removing an element from the stack, now the 4 will be removed. Okay, we can't remove 1 2 and 3 before removing the 4. Okay, so this 4 get removed. Now again, if I try to remove, this 3 get removed. Again, if I try to remove, the 2 get removed. And now again, if I try to remove, the 1 get removed. And now you can see there is no more elements in a stack, and if I try to remove one more element, it will throw us an error. Okay, so till now I'm assuming that you get a little bit approach that how this stack actually works. Okay, so I hope that you get a little bit approach. So till now what we discussed, we know that inserting an element in a stack is seen just like the other data structures. Means we keep on inserting the elements in a stack just like other arrays and the array list. Okay, it is similar. Okay, but when it comes of removing an element from a stack, we can only remove that element from a stack which is currently inserted, means which element is at the top of a stack. Okay, so means here we need to maintain a variable that is nothing but a top, and this top element, okay, wait, let me write in some other color, and not top. Okay, and this top variable that we declare or we maintain throughout the usage of stack, this variable only help us to tell that at which position we can add an element or at which position we can remove an element. Okay, so okay, so let's again try to implement it and then again try to understand it. So what we have done till now, wait, just may remove it. Yeah, so what I was saying, what we have done till now, we get a little bit approach how the stack works. Now we again trying to implement it. So The first thing is inserting an element into a stack. We know element is inserted just like other data structures, means we can easily insert element one after the another. So I insert one, two after one, then three, after three, four, after four, five, after five, six, after six, seven, after seven, eight. Okay, I'm assuming that I till now I have inserted all the elements. Okay, you can see I have inserted all the elements. Now the one more thing about this stack is that I told you just a little before that in the arrays we can perform something that is known as random accessing. Means we can access an element from any index. Okay, but if I talk about the stack, we can't perform the random accessing. Okay, it allows only two operations, actually three operations. It allows only three operations, that is adding to a stack, which is known as, if I talk about the stack, the adding an element into a stack is named as push operation. Okay, this is known as push operation. Similarly, removing from a stack, removing an element from the top of a stack, that is nothing but the pop operation. Similarly, there is one more operation which is most commonly used in a stack, that is not a peek operation. So what is this peek operation? Okay, so as in array we can perform the random accessing, but in stack we can't perform the random accessing. But you might be thinking that how can we access the element? So just to access the element we use this peek operation. Okay, so means we can use this peek operation, but we can't perform random accessing. So which value this peek will return? Okay, so it returns the value that so it only returns that value to which pop is currently pointing. Okay, so we know that top always points to the top of the stack. Sorry, top only points to that element which is currently inserted. So we know that at the very top of a stack means the currently inserted element to a stack is nothing but this 8. So top is pointing to this 8. If I ask from the stack that please give me some element using this peek operation, I am accessing this peek operation, please give me some element. So it will ask, the stack will order the top that give and value to that position to which you are pointing. So this top will return 8. So whenever I use peek, at first when I use the peek, I will get 8 as a result. Okay, so what we are going to do right now is that we try to use both of these three operations one by one, and we keep on deleting element. We keep on deleting element from a stack, and during deleting we keep on adding some elements. Okay, then so that you get a deep intuition about both of these three operations. Okay, so we know, okay, wait, let me a little bit. So here it was 8. So we know that we have three operations, that is push, pop, and peek. Okay, so the first operations and our top is currently pointing to here. I hope till now you know that what is this top, what is this push, pop, and peek. Okay, so at first what I'll do, I will call the peek operation. What the peek does, peek go to the stack and ask that I want to access some element. Now what the stack does, stack orders the top that give me the value of that position which you are pointing. So top is currently pointing to this position at whose value is 8. So I will get this 8 at first. Now what I'll do, I will pop. Okay, so what the pop does, pop go to the stack and says that I want to pop an element from this stack. Now it means that I want to remove some element from the stack. Now what the stack does, stack orders the top that remove that element to which you are currently pointing. Means here the top is currently pointing to a position at which 8 is stored. So what happened, this position get removed out. Okay, this value get removed out from the stack and top start pointing to this 7. Okay, here you can see how the pop operation works. Okay, now again I will call the peek operation. What the peek does, peek returns the value at the top of a stack. So here the top is at position is at some position where value 7 is stored. So I get 7 in my output console. Similarly, again I will perform pop operation. What the pop does, pop remove an element from the position to which top is pointing. So, or I can say that pop removes an element from the top of a stack. So this 7 get removed out. Okay, and this top start pointing to this 6. it reaches here. Again, I'll call the peak operation. Okay, I'll call the peak operation. I'll get 6 here. I hope you get it, that how can I get 6 here. Okay, now as I get 6 here, again what I'll do, I will call the pop operation. This time again, as pop is called, this value 6 value get removed out from the stack and top start pointing to the 5. Now I'll perform something different. What I'll do, I will call the push operation. What the push operation does, push operations, like I have called the push operation goes and what the push operation does. Okay, so the push operation, like we have called the push operation, and push operation goes to the stack that I want to insert some element to the stack. So what the stack order is to the top is that stack orders to the top that insert the element, the value which is taken, just took an value from the push and insert that value at the top of a stack. Okay, so what the push does, it's I'm assuming that I'm inserting 10. Okay, I'm inserting here 10. So what the top does, it insert its value at here and start point. Now my top start pointing to here, it keep on start pointing here. Okay, so this is the push, pop and peak operation of the stack. I hope you get it, that how it works. And what are the memory, not the memory, what are the pictorial representation of stack. We generally shows the stack using this type of diagram. Okay, so let's move on to the code and let's try to write some code and then try to understand it, how we implement the stack in the Python. Okay, so here, this is our Pepcoding portal. So we are going to write the code here. The very first thing about the Python is that there is no such stack data structures, means there is no such implementation of the stack data structures, just like we use a stack data structures in the C++ and in the Java. There is no such implementation in the Python. So how do we implement the stack in the Python? Okay, so the first thing is that stack is not a data structures, it is a behavior which we want to access. So here you can see that whatever I explained here till now, I've just told you the behavior, that how the stack works. Okay, so what we are going to do is that we are just going to use the list as a stack. Okay, so list have some operations like the push back, pop back. Okay, so we will use those functions to implement the list as a stack. So what we'll do, we will create the list of the name stack. So here I'm creating a list of our name stack. Okay, stk stk signifies the stack. Okay, so now what we'll do, we will append some data to the stack. This appending is nothing but a push operation in a list. Okay, so here I'm appending some data, stk.append of a stk.append of b. Similarly, stk.append of c. So here I have appended a, b and c. So you might be thinking that how this append operations works similar like the push operation. Okay, so for that, what I'll do, let me explain you here. Okay, so here I'm assuming that I'm creating a stack. Okay, I'm assuming that this stack is get created. Okay, so one more thing is that there might be a possibility that you are not able to see the code. Okay, just because at first, just because of this. And one more thing is that the font size. Okay, let me increase it. Yeah, it is visible now. Okay, so yeah, I was explaining you the stack. Okay, so we know the append operation in a list add all the elements at the end. Okay, so what happened, that whenever I insert an element at a, this a get inserted into the list. As the list is empty, the a get inserted freely. Okay, now when I add the b, when I append the b to my list, so what happened, that this b get added after this a. Okay, so this is the we can see the functionality of the append function, or we can see the property of an append function. It always insert an element at the very end. So similarly, when we add c, the c get added here. Okay, So let's try to print it. Okay, so let me remove it. Yeah, we will printing. Let's try to print initial. Okay, wait, print initial stack ini, and we will just print stk. Let's try to run it and check it what are the elements are actually stored in our stack. Okay, so let me take it from. So here you can see that in the stack A, B and C are actually stored. Now let's try to remove an element from the stack. This is an initial stack. Now what we'll do, print elements after popped out. Elements popped out from the stack, popped out from the stack, Okay, so at first we will stk dot pop. Now similarly, like the append function, as the append function insert an element from the AND, what the pop function does is that pop function always removes an element from the AND. Okay, so here you can see that according to a requirement, what we required, just we have inserted A, just after A we have inserted B, we have inserted C. So this is nothing but behaving like the push operation in the stack. Similarly as the pop, when I implement the pop operation, what the pop operation does, at first it removes this C, then it removes this B, and then at last it removes this A. So it behaves like the original pop function of our stack. So let's try to code it and then try to understand it, whether it will behave, it will behave as we are assuming or not. Okay, so we write print stk.pop, stk.pop. Similarly again print stk.pop. Okay, so let's try to run it again. So here you can see elements from the popped out. At first C get removed from the stack, then B, then A. As C is the last element which is inserted into the stack, similarly C is the first element which is removed out from the stack. So this is nothing but a stack behavior which we have implemented using the list in a Python. So I hope you get it, that how we implemented the stack, what is the behavior of a stack. So actually stack is a behavior. It doesn't require any of the data structures. In some of the language like C, C++ and Python and the Java, we are provided with an additional data structures having the name stack, which also works on the same functionality. But if we are not provided with any data structures, it is means it is not necessary that we always provide with the data structures. Okay, so means we can easily implement this behavior using any of the other data structures as we have done here. So I hope you get the idea of this video. If you like this video, don't forget to hit the like button, subscribe to our YouTube channel, and please share this video with your friends. And in the coming videos we will solve similar question, some interesting questions on the topic of the stack. Till then, stay safe, stay healthy.